Okay, and welcome to this first video, well, one of the videos in statistics where we're going to look at correlation and regression. It's quite a straightforward topic really, and there's quite a bit of straight lines knowledge within this. So I'm just using this document here, which is obviously from the class, from the workbook, and then we'll go through this page. I'll recommend some questions for you to do in the textbook, and obviously we'll take it from there. So correlation and regression, you've actually seen some of this before in GCSE. Okay, so I'm just going to get my pen here. Now, with regards to correlation, you've definitely seen that word before. That's used to describe a relationship between two variables when they have a linear association. So if you remember GCSE, you said positive or negative or no correlation, and obviously you might have used the word weak or strong, which is obviously described here. Now, there are two types of variables that we need to understand if we're dealing with a correlation or regression question. The first is the explanatory variable. So the explanatory variable, or the independent variable, this is the one which is controlled in the experiment, is normally plotted on the y-axis, on the x-axis. Likewise, the response variable, it's in the name, depends on the explanatory variable. It responds to the explanatory variable, and that's normally plotted on the y-axis. A causal relationship exists if a change in one variable causes a change in the other. The context of the question must be considered to determine whether a causal relationship is sensible. Now, with regards to A-level, especially A-level statistics, the context of the question, sorry about that, the context of the question is very important. Okay, so it's not just enough to just say positive relationship or negative relationship. You have to say, okay, what's going on in context, okay, between the two variables. Now, the regression line, this is a concept or term which is probably new to you. Regression line of y and x is given by y equals x plus bx and gives the equation of the line of best fit. So at GCSE, when your teachers explain to you, okay, draw a scatter graph and draw a line of best fit that cuts as many points as possible, then that was called line of best fit. At A level, we call that the regression line. Okay, and it's given obviously in a straight line form. A plus bx, b is the gradient, a is the y-intercept. Okay, so we've got this example here. We've got a biology experiment, and it's carried out to investigate the effect of water temperature on the oxygen output of plant life in a tent. Okay, so let's just try and understand the context. We've obviously got some plants in a tent, and we're increasing water temperature, and we'll see what the oxygen output will be like. So we've got our table here, water temperature against oxygen output. As you can see, the water temperature is going up in 5 degrees each time, and you can see the oxygen output as well. Now, part A, identify the response and the explanatory variable. Now, remember, the response variable depends on the explanatory variable. So let's just try and see what the explanatory variable is the one which is controlled in the experiment. Now, clearly, if you're looking at both of these variables here, then water temperature, that must be the explanatory variable. Okay, so the explanatory variable is water temperature. Okay. Now, in terms of the next type of variable, obviously that leaves a response, which is going to be the oxygen output. Okay, so identify the response variable and explanatory variable. So the explanatory variable is the water temperature, and the oxygen output is the response variable. Okay. Draw a scatter graph. So part B. Now, I'm just going to show you, obviously, I don't want to go through the process of drawing a scatter graph, but this is what it would look like. Okay, if you'd gone up in 5s and you plotted all your points, that's what your scatter graph would look like. Okay, so you go up in 5s along here, water temperature degrees Celsius, you've got to make sure you give the units, going up in 1s here along the y-axis, oxygen output given with the units milliliters per minute. Okay, I wouldn't assume that's a very difficult skill for you guys to do at this level. Describe the correlation in the context of the question. So when we talk about correlation in the context of the question, what we have to understand is we can't just say positive correlation. We have to give the context. So positive correlation, that's definitely there. As water temperature increases, oxygen output increases. That's the sort of statement that we're looking for at A level. Okay, not just a blank two-word statement. We've got to make sure we've got to write things in context. As water temperature increases, oxygen output increases. Or you could say there's a directly proportional relationship between the two. Now, the regression line is calculated to be this: y equals 2.11 plus 0.228x. So what they've said is that they found the equation of the line of best fit. Now remember, this is a straight line equation. So if you look at this carefully, the number next to the x, that's your gradient. Okay, and the number here, 2.11 on its own, that's c, that's the y-intercept. So if we had to draw this line, which is what they're saying in part D, draw the line on the scatter graph, well, 2.11, that's easy. That's going to be there. That's your y-intercept. But how do you draw the rest of the line? Because you need 2 points. What I always say is, make a coordinate. If you can pick, let's say, x equals 10 or x equals 30, why not substitute that in to the equation, find what the y value is, and then you can plot another point. So if you substituted in x equals 30, you can get another value here, which looks like roughly 9 or something. Okay, and then you can draw the line. You can draw your regression line. It's as simple as that. Okay, so remember, the number in its own is the y-intercept. Sub in an x value and get a y value. Create a coordinate. So that's not too difficult, drawing a line, drawing the regression line on the scatter graph. And you can see it's not a bad line of best fit. Most of the points pass through it. We've got an even number of points either side. Quite a good line of best fit. Use the equation to predict the oxygen output for a temperature of 18 degrees centigrade. So let's just understand this. The x variable, that is your water temperature. Okay, so if we substitute x values in, we'll get y values out. And what are the y values? That's the oxygen output. So let's substitute in x equals 18 into this equation for x. And if you were to do that, you get 6.214 milliliters per minute. And you have to make sure you give the units. So we've done that. Explain why is it inappropriate to predict oxygen output for a temperature of 60 degrees. Now, with these sorts of questions, guys, it's very clear that there's going to be some extrapolation. Extrapolation means we're going outside the range of recorded data. So we've only got up until 40 degrees here. Now, if you sort of think about it, 40 degrees is hot for a human being, very, very hot for a human being, let alone plant life. So, 40 degrees, it's pumping out a lot of oxygen. But when you get to 60 degrees, I think that will be outside the range of data, definitely. And it's not reliable. The plant might burn. It might just be cooked. A human being at that temperature will probably burn quite badly, let alone a plant. So I think, always sort of think about that in context. And this sort of question here is quite interesting. And they like asking this. Interpret the meaning of the gradient and the intercept of the regression line in the context of the experiment. Right, remember, what is your gradient? Your gradient is 0.228, and your y-intercept is 2.11. Now, some students struggle to do the explanation with this. Just break it down in terms of really what is the gradient. When you were taught gradients way back in September as part of straight lines, you were told it was the change in y over a change in x. Okay. Now, if you think about it, in context, what is gradient? That basically means per unit x that you go across, how high are you going up? That's basically what it means. Okay. Per unit x, how high are you going up? So 0.228, yeah, If we think about that, in this context where we've got a graph, x against y, where x is water temperature and y is oxygen output, then 1 unit across will be 1 degree across. And 0.228 represents how much oxygen output is given per degree of temperature. Okay, so 0.228, if you to interpret the meaning of 0.228, the gradient is changing y over changing x, which means how far you're going up per unit x along. So per 1 degree Celsius, the plant is increasing its oxygen output by 0.228 milliliters per minute. Okay, and finally, the y-intercept. Now, the y-intercept, that is the value of y when x is equal to 0. In context, what does that mean then? That basically means when we've got a water temperature of 0 degrees, what is the oxygen output? And that means that at 0 degrees, the oxygen output is 2.11. So if we were to reword these questions, 0.228 milliliters, which is the gradient, is the increase in oxygen output with every 1 degree increase in water temperature. And the intercept of 2.11 is the oxygen output at 0 degrees, i.e. at freezing point. Okay, so that is this primer on correlation and regression. The key themes are outlined here. What kind of skills do we use? Understanding what's response, what's explanatory, drawing a scatter graph, describing correlation, drawing a straight line equation. You got y-intercept, you got a gradient. Using that equation to find temperatures, thinking about suitability of the model, and interpreting the meaning of gradients and intercepts. Okay, so that's the end of this video, and there are some questions here that are well worth having a go at, and a stretch and challenge question here as well. And that's the end of correlation and regression as part of the statistics aspect of Year 12 maths.